Let's solve the exponential equation base x to the second power times base 10 to the x power minus base x to the first power times base 10 to the x power equals 2 times 10 to the x power. Now here's a big hint. You never want to simplify this by dividing both sides by a variable. Even if there's a variable in the exponent, you want to be careful. The main thing is never divide by a variable because it may be equal to 0. So instead of dividing by a variable, we're going to factor. So step 1, we're going to isolate the exponent by factoring. So we're going to pull out the common factor of 10 to the x power. 10 to the x power. So that gives us 10. Well, let's turn this fraction around and write x squared minus 10 to the x minus x. I just moved the 10 times 10 to the x to the left side. That's all I did there. And now I factor 10 to the x. It leaves x squared minus x minus 2. You can check that to make sure that's good. Now I'm going to use the zero product property. And that says when you have a product a times b equal to 0, you can deconstruct that as the first factor a equals 0 union together with the second factor b equals 0. That's what we're going to use. We're going to take the first factor in our factorization, 10 to the x, and set it equal to 0, union that together with the second factor, x squared minus x minus 2, and set that equal to 0 since their product equals 0. Now, on the left, we have 10 to the x equals 0, and that's not going to be a good solution. And that's because 10 to the x is never going to be equal to 0 for any x value. So the contribution there is there's no solution. It's just the solution set is empty. And by the way, I just want to stop and say that it actually wouldn't have been a violation of the rule of dividing by 0 if I had divided both sides by 10 to the x, because it's impossible for 10 to the x to equal 0. So that really wouldn't have been a violation. It would have gotten rid of the 10 to the x. I'm always super careful about not dividing by things that have variables in them, because I'm always thinking, wow, what if that x value gives me a 0 denominator? I don't want that. So I factored instead. But anyway, the 10 to the x disappeared because it's not ever equal to 0. And then we have to solve the other one. Now let's see if we can factor x squared minus x minus 2. Yeah, it factors as x minus 2 times x plus 1. And bring down the equal sign and bring down the 0. Don't forget that. Set each of your factors equal to 0. X minus 2 equals 0. Union together with x plus 1 equals 0. Solve. We get x equals 2 and x equals negative 1. Now we need to check our solutions. Be careful, you need to check our solution. Now, I know, let me say before I get into this, x equals 2 is going to work. I'm going to take you to the end here. Yeah, it works. It works. But x minus 1 doesn't work. It looks like it's going to work, and I go through all this calculation here to show you by plugging it back into the original equation, but then I go, hey, wait a tick. X is the base in the given equation. It's the base portion. And if you look back at note 115, we said that the base could not be equal to 1. It cannot be equal to 1, and it has to be greater than 0. If x is truly equal to negative 1, like I'm claiming here, it's not greater than 0. So I can't keep it. I have this restriction on my base value here, so I'm going to get rid of that and just keep the x equals 2 solution. You know, you always have to go back to that note 115 and make sure that you haven't violated any rules when you're working on this thing. So go back and study note 115, the little small print.